Hi and welcome back to R for BRFSS. I'm Jennifer, your instructor for this tutorial series. We are now in the third and final video on a three-part segment for additional preprocessing. So we just finished combining multiple years of data and attaching our identifying information. Next, we are going to learn how to reorder factor levels and also set reference values. So let me open back up R. This is the same R session that I've had open for the last two videos. And what we want to do before we start reordering our factor levels and setting reference values is I thought it would be easier to first subset our data file to just contain a couple of variables. So now we are working with the IDCA 15, 16, 17. So this is the data from California over 2015, 2016, and 2017. And it has attached to the front of it some identifying information. So on this data file, we're going to pipe this into the select function where we're going to select these variables. So, if you were actually going to analyze this data, you would probably want to keep in your weighting variables. So that's the PSU, primary sampling unit. That's the respondent identifying information. Like respondent ID. The LLCP weight is the weighting variable, and then this STSTR is the stratification variable. So these are the variables that you would use to set your survey design. I just want to keep in our ID1 and ID2 variables, which were the fake kind of identifying variables that we made in the last video. And then we have a couple of other variables that I thought might be interesting to include for this example of setting the reference values and reordering factor levels. So we have sex, education, employment status, income level. RFBMI 5 is overweight or obese, and this X_Totinda is somebody who has not exercised in the last 30 days or somebody who has exercised at least once in the last 30 days. So it's the physical activity question. All right, so I'm going to select these variables on this data file, and I'm going to rename, I'm going to set that to the object name, IDCA 15, 16, 17 S for the variables that we selected, S. Okay. So let me just copy that and paste it in. Let's glimpse IDCA IDCA 15, 16, 17 S, and we have 11 variables, and we still have all 33,000 of our observations. All right, good. And we have cleaned a lot of data in this tutorial series, so you already know how to, set a variable to a factor, and then recode it according to whatever specifications, right? So I'll just really quickly review this. So this command, we want to set the variable as a factor because in the original data file, it reads in the variables as numbers. So this DBL means a double, that's a number. But as we know, a lot of variables in the BRFSS survey are actually factors, they're not numbers. So we want to reset the variable as a factor and then recode that variable based on the response options that are in the BRFSS codebook. All right, and if you need to find the BRFSS codebook, that's, okay, let me show you how to get to the BRFSS codebook in case you forgot. So you go to the internet, you type in CDC, BRFSS, whatever, 2017. You click on the first result, and then the codebook on every page is right under the survey data information. All right, so if you need to know what response values correlate to what actual response option, so for example, let's search for the variable, let's search for the variable, for the sex variable. So on this variable, the value is 129, and the value labels are male, female, or refused. So if we want to work with this variable, we have to recode those values to 1 equals male, 2 equals female, and then I just set the default and the missing value to NA. Because it's either missing or it's refused, and if that value is refused, we're still not interested in analyzing it anyway. So, and then also, if this notation looks unfamiliar to you, this $, this just means that we are looking in the data set. So this is our data frame, our data file is IDCA 151617S. This $, means to look specifically at the column called sex. So we are looking in the data file at this column, sex. We are setting it as a factor, and we are recoding the values to a value label, all right? And we're going to do this across the sex variable, the education variable, the employment variable, the income variable, the BMI, so overweight obesity variable, and the physical activity variable. So let me just leave that on the screen for a second for you to look at. You can pause now and look at how we're cleaning each of those variables. I'm not going to talk through each one individually because we have cleaned so much data in this tutorial series. So there it is. I'm going to scroll up now because I think my video is here. So that's how we're cleaning it. All right, I'm just going to copy in this chunk of code. Copy and paste. All right, and we do get one error message about recoding the income variable because it said that it coerced missing values, or missing values were introduced by coercion. And I think that just has to do, so I'm not really sure why we always get this message when we try to clean the income variable. But when I look at IDCA 151617S, and I look specifically at the income 2 variable, I get my responses, right? And we have our levels. So it looks like everything is clean and it's fine. I'm not quite sure why it always tells us that missing values were introduced by coercion, but it seems like it doesn't affect my analysis. So I'm hoping it doesn't because I don't know how to resolve that. But we do get the right levels. Let's take a glimpse at our data file now with our clean variables. So IDCA 151617S, and we can see that the variables that we set to a factor are factors, and they have their factor levels here, and it looks clean. It looks good. All right. So we've selected a couple of variables and we've cleaned that data. Now what we want to do is reorder some factor levels. So for example, if I look at the levels, so this is a function called levels. It lets you look at the levels of a certain variable. So we're looking at the sex variable, $, that is in this data file, IDCA 151617S. So let's look at those levels. And it gives us the levels female, male, NA. And that is because R assigns the levels alphabetically. But let's say we didn't want it to be in alphabetical order because, so this could be an issue if you're running some analysis and you have a figure, like a graph, and on the x-axis you have the respondent's sex. And if R sorts that factor alphabetically, you'll have female, male, NA. But let's say instead you wanted male, female, NA. Then you would have to first reorder your levels. Okay, so to do that, we take the levels of this variable and we assign this order. So we do levels of IDCA 151617S $sex, put the assignment arrow, and then this C parentheses, which I call contains. So that contains the levels in this order. So first male, then female, then the missing values. So when we run that, and we look at the levels again, now we see it's male, female, NA. All right. So yeah, you can reorder your factor levels by, setting the assignment arrow to contain the order, your levels in the correct order. And that might not be a huge issue for the sex variable because, male or female, female or male, maybe doesn't matter. But for something like income, it might matter, right? Because you would probably want to plot income in order of least to greatest, right? So if we look at the levels of income as they are right now, let me make this bigger. Okay, so if we look at these levels of income, it starts with 10 to 15K, 15 to 20K, 20 to 25K, 25 to 35K, 35 to 50K, 50 to 75K, then greater than 75K, and then less than 10K, and then the missing values. All right, so obviously that doesn't make sense for the smallest amount of income, less than 10,000, to be at the end of the list. All right, so if you plotted that, it would look silly. So we want to reorder these factor levels so that less than 10K is first, and then less than 10K all the way up to greater than 75K. So to do that, we are going to rewrite that object. So this levels IGCA 15, 16, 17S $income2. Set the assignment arrow so that those levels contain the factors in this order. So first, less than 10K, then 10 to 15, 15 to 20, etc., up to greater than 75, and then just put the missing values on the end. So when we run that code and we look at the levels again, we see that it's in the correct order. All right, less than 10K, all the way up to greater than 75K, and then the missing values, which you can decide what to do with the missing values later, whether you wanted to omit them in the beginning or keep them for now and then omit them later. It doesn't matter. But the important thing is that now our actual factor levels are in the correct order. All right, so it's the same process for reordering factor levels for any of the variables, right? You call in the object name wrapped by that function called levels, put the assignment arrow, and then C parentheses, the order of your factors, the order which you would like your factors to be in. And you can do that across all of your variables. But let's say that you wanted to do like a regression analysis. And now you have reordered your levels so that, for example, on the income variable, you've reordered your levels so that less than 10K is the first value. So when R runs your regression analysis, or whatever analysis which may require a reference level, it will read in the first level. It will read in the first level of your factors as the reference level. So the way that we've organized these levels, now less than 10K is the reference. But let's say that you wanted, for example, maybe you wanted greater than 75K to be your reference level, because maybe whatever your hypothesis is, you're interested in, compared to the people with the greatest income, what is the health status of people with lesser incomes, right? Whereas the way that these factors are leveled or ordered now, the way that you would have to ask that question is compared to the people with the least income, what is the health status of people with greater incomes? But, you might be interested in the opposite question. So you would have to set your reference level to greater than 75K. So in order to do that, what you want to do is you can either reorganize your levels like this, but I think the more formal way for setting a reference level is by using this function called RELevel. So you'll see the difference between these two codes is that here you set the levels as the object, and then you tell R the order of the factors, which order you want your factors to be in. All right, but when you use the RELevel function, what you're doing is in this column. So for example, the overweight obesity column. In this column, you want the reference level to be 1. All right. So when we cleaned our data earlier, 1 means somebody who is overweight or obese. So let's say you want that reference level to be 1. So with the RE level function, all you have to do is tell R what you want your reference level to be. All right, so that's the example for overweight and obesity. For example, for physical activity, maybe we also want the reference level to be 1. Maybe for sex, we want the reference level to be female. For education, maybe we want that reference level to be a college graduate. For employment, maybe we want the reference level to be somebody who is employed. And then finally for income, maybe we want that reference level to be somebody who has greater than $75,000 of income per year. All right, so that is how we set the reference levels. Let's copy in that chunk of code. And then if we look at the levels, for example, of income 2, let's see. Levels of income, I need to specify the data frame. So levels of IGCA 151617S $income 2. Now we see that the first level is greater than 75K because we have now set that to the reference level. But the other levels are still in the correct order, right? It didn't reshuffle everything, because if it did, then it would have put less than 10K back at the end if it was trying to keep it alphabetical as it had initially before we reorganized the levels the first time. All right, so when you set the reference level, R puts that in the beginning, and then when you're running some analysis that requires reference levels, it holds that factor level out and compares everything else to that 1. All right, and let's for example also look at the levels of sex. So we set female as a reference. Maybe we want to look at X_RF BMI 5, 0, 1. So now we've set our reference levels across the variables in our subsetted data set. And so in conclusion, the point being is that depending on what you're using your data for, if you need to plot it, you would want to organize your levels according to, the way that you want your plot to look, right? So for income, it makes sense that you would want to have your levels organized in order of increasing value. But then if you're running some kind of analysis that requires a reference level, you would have to set that out separately. So depending on what you need to reorganize your levels for, right, depending on whether you're using it for visualization or for analysis, you may have different objectives for reordering your factor levels. But regardless, now you know how to do it both ways. So, all right, that is all I wanted to cover in this video, and I believe that concludes this segment on additional pre-processing. All right, and then the reason, finally, the reason why I thought that this was a really important topic is because I really feel that if you know how to clean your data, you can figure out how to analyze it, right? If it's just a matter of deciding what tests to use and what arguments to put into your function, that's the easy part. A lot of times, the hard part is figuring out, gosh, why can't R even read my data? All right, so if you can clean it, you can analyze it. And that's all I wanted to talk about for this tutorial segment. So let me just close out my Word file. I'm done with R. I don't need to save the workspace. Go ahead and close out the internet. And so thank you for joining me with this one. Come back next time and I'll have more content for you. So thanks again. Bye.